Hi guys, today we are working on simplifying radicals when they have negatives inside. So we know that we're not able to simplify a radical if it has a negative inside without using the letter I. So normally in the previous lessons we might have said no real solutions, right, or no real roots. And that is a totally fine answer for some situations, but in some situations we want to actually know what that number is, and we actually can do it. It's called an imaginary number. And so what that means is that we're going to take this, we're going to split it into the square root of negative 1 times 4. Right? So we're allowed to do that because negative 1 times 4 is the same as negative 4. We can then split that into the square root of negative 1 and the square root of 4, which means that we have the square root of 4, which is 2. And then the new thing that we've learned recently is that this negative 1 here, square root of negative 1, is what we call the letter I. And so the letter I represents that. And so 2 times I is just, we write 2I. And that would be our answer there. Some mathematicians would put plus and minus there because technically it is two solutions. It's the positive version as well as the negative version. When we look at the second one here, it says negative square root of 81. So this one's sort of a trick question. You have the negative outside, and then you have the square root of 81. Square root of 81 we know is 9, so we have just negative 9. This is different from when we had negative 81, square root of negative 81. So the negative would stay outside. We know that the square root of 81 is 9, and we know that because there is that negative there turns into an I. So the answer to this problem would be negative 9I. So we can see that those are different because one asks us to use the negative inside and one doesn't have a negative inside, even though they both have the negative outside. So moving forward, we're going to look at what happens when we don't really know, like 81 is an easy number, but negative 32, not so much. So I'm going to take 32. I'm going to try to simplify this. I know that it's 2 times 16, and then I know it's 2 times 8, which is 2 times 4, which is 2 times 2. I'm looking for groups of 2 here, so I'm going to take out this group of 2 and that group of 2. That means that I have 2 times 2 on the outside. This negative is going to create an I on the outside, and then what's left over inside is this last remaining 2. So I'll have that there. 2 times 2 is 4. I still have the I and the square root of 2. Right? Feel free to Google simplifying radicals. That will help you find videos if this process is still tricky for you. So that is what you should Google if you need some help there. There's a couple more examples, so we'll work through them. So on this one, it says 2 square root of negative 18. So I'm going to split up the 18 into 2 and 9. The 9 splits into 3 and 3. I see a group here. That means the 3 is going to the outside. So I have the 2 from before. I have the 3 from here. I have the negative is going to create an I on the outside. And I still have left inside just that singular 2. That's all by itself. So I have the 2 there. Simplify this. I'm going to get 2 times 3 is 6. I square root 2. That is my answer there. For this one here, I know that the square root of a fraction is the same as the square root of 1 over the square root of 9. Right, so I have the square root of 1 is 1, square root of 9 is 3. I know my answer is 1/3. If there had been the negative 1/9, like that, I would have taken the I to the outside because of the negative there. And then I would have done the same thing, square root of 1 over square root of 9. That means I times 1 over 3, just like we talked about right here. And so then I'd have 1/3 I as my answer there. That's a separate problem, right? So I just changed the problem a little bit there, but we see that in both situations, we see that difference. We see the only difference between having a positive number here and a negative number is that my answer includes I on this case. Then our final problem here has 5 square root negative 54. So 54, I will split into 2 and divide that by 2. I get 27. 27 is 3 and 9. 9 is 3 and 3. I'm looking for pairs. That pair is there. So I have the 5 from before, the 3 that I just pulled out here, and I was left with a 2 and a 3 inside. So inside I'll have 2 and 3, 2 times 3. And then that negative is going to create the I on the outside. So here I have 15I. Square root 2 times 3 is 6. Have my final answer there. Remember to Google simplifying radicals if you need some help in the factor tree part. Otherwise, if you see a negative inside square root, pull it out, call it an I. Thanks, guys.